Before we continue on with some more examples, first I want to give you some guidelines for working with word problems. Kind of said this a little bit already, but want to put it down and be a little more formalized. The first thing that we do is we want to determine what is unknown. Right? What is it in the problem that we don't know? So that we can start trying to find what we don't know. And so the second thing is we want to represent the unknowns using expressions involving just one variable. We only have a single variable at our disposal. So when we have multiple unknowns, like we did in the example a little earlier, we have to find ways to represent all those unknowns using that variable. And then once we have expressions for each of our unknowns, we then want to come up with an equation. That usually involves another sentence in the problem that we haven't really touched on yet in that particular problem. And so we use that to come up with an equation. Once we have an equation, we've done the really hard work. Generally speaking, these equations compared to what you've already done will be pretty straightforward. So then we solve the equation and then answer the question or questions. Sometimes we just have one question, and that'll often be the answer to the equation. Other times we have to do something with that answer to come up with the other things that we don't know. And as we will see, we see this a lot more in the next section with mixture problems. But charts and diagrams and tables can often be helpful tools as we begin to try to work these problems out. So with that in mind, let's tackle our next problem. Our next problem tells us that a 64-inch board is cut into 3 pieces. A 64-inch board is cut into 3 pieces. It's cut in such a way so that the second piece is twice as long as the first. The second piece is twice as long as the first. And the third piece is 8 less than 3 times the length of the first piece. 8 less than 3 times the length of the first. Okay, we continue reading here. Determine the length of each piece. Determine the length of each piece. Okay, so the first thing I've done here is I've made some little marks to indicate a few things. The second piece is expressed in terms of the first piece. Second piece in terms of the first. Notice also that the third piece here is expressed in terms of the first. So that means it would be a good idea to make x be my variable. So then what I've done is I've drawn my board. I've drawn my board, and I know that my board is 64 inches long. 64 inches long. So I can label that. And I'm going to divide this up into 3 pieces. The first piece then I'll call x. Okay, since both the second and third are in terms of x, in terms of the first, we can make that one be our variable. And then divide it up another time. So since the second piece is twice as long as the first, twice as long as x, that would be 2x. And then the third piece we read here is 8 less than 3 times the first. 8 less than 3 times the first. Remember, less than is that backward subtraction. So 8 less than 3 times the first, 3x, minus 8. At this point, we've worked out expressions for each of our 3 pieces. First, second, and third. All in the same variable, x. So at this point, we now set about solving the problem. And so what we know is we have a 64-inch board. It's been cut. Now, we're talking here mathematically about ideal cutting. So, in other words, nothing gets lost. If you've ever cut a board with a saw, you know that's not true. Because there's a whole bunch of little stuff laying all over the place now that got removed from the board. Yeah, the sawdust. Usually, in general, when you cut with saws, cut wood with saws, you're losing about 1/8 of an inch on every cut. So if we want it to be ideal, these three pieces can't be put back together to form the 64-inch board in an ideal situation. But here, we're going to make that assumption just to make life easier on it, so we don't have to deal with taking off 1/8 of an inch for every cut. So with that in mind, then, all three pieces should come together to give us our 64-inch board. Our 64-inch board. And now we can set about solving this problem. X plus 2x plus 3x. If we combine our like terms, that would give me 6x minus 8 equals 64. And at this point, we want to solve for x, so we bring the variable over to the other side by adding 8 to both sides. That gives us 6x equals 72. So then to solve for x, we need to divide both sides by 6. So we go ahead and do that. 72 divided by 6 would give us x equals 12. X equals 12. And then we just continue working out this problem. Continue working out this problem. So x is 12. We want to know the length of each piece. Right? We want to know each piece. So the second piece would be 2x, or 2 times 12, which would be 24 inches. And then the third piece, we would say 3 times 12 minus 8. 3 times 12 is 36. Minus 8 gives us 28 inches. So our three pieces are 12 inches, 24 inches, and 28 inches.